Hey, welcome back everybody to the routing loop. Good to see everyone again. Hi, Tom. How you doing?
Hey, I'm
Long
great.
time no share a stream.
Yeah, I think it
Uh,
was 2 weeks ago or 3 weeks ago we were on the same stream.
exactly. So what happened last week, Tom? As you know, I was covering the architectures for VPC Lattice, and we were going through a bunch of things. And then Alex, not last week, the week before, but then Alex went ahead and did the demos for VPC Lattice. And then I was asking in the chat, hey, who wants to see more demos? Who wants to see more about resource endpoints? And everyone's like, yeah, more on resource endpoints and more on demos. So Tom, what are you doing today?
So I'm going to cover endpoints. There's different types of endpoints that we can talk about. We have interface endpoints, which have been out for quite a long time, and we'll go over them today as well. But the newer type of endpoints are the resource endpoints. That we'll cover both. We'll show you how they look like. We will do some demos. We'll do some whiteboarding.
Demos.
Yep,
Okay.
yeah, there will be demos. There will be some slides in the beginning, but I think I only have 12 slides, which is very low for my usual.
Yeah, I know. Usually you like to break every animation out on its own slide, so that's pretty crazy.
Yep, yep.
Perfect. So we'll be sure to, of course, to ask you a lot of loads of questions. And if anybody else, of course, wants to hear about anything specific, please feel free in the chat just to let us know what you want to hear, what you want Tom to focus in on. But why don't you kick us off, Tom?
Cool. All right. So I can't see the screen, so I don't know if you're sharing already or not. Are we
I
sharing?
am sharing your screen. We have your
One,
slide deck up.
wonderful. So I thought not everybody here might have seen all of the sessions in the last 3 weeks. If you haven't, they're all on demand, available on the routing loop. But I'll do a very, very quick recap of what we talked about before, right? Just a summary, just so we're on the same page. So we introduced the two different connectivity models, the traditional network-to-network connectivity, where you're connecting a client VPC with some client with the application VPC, where you have some resources that you want to get to. You set up your routing, and then you send traffic through that network-to-network pipe. You're ultimately exposing the whole VPC of the client to the whole VPC of the application, and then restricting access with things like security groups. And then the other component that we spent most of the last 3 weeks on was application networking. So that is where you do some magic. And rather than creating network pipes, you're making it look as if the resources in the application VPCs are actually hosted in the client VPCs. So they would appear as IP addresses, interfaces inside of the client VPC, so the client can connect to something that seems and looks and feels like it's local, where in reality it's in a remote VPC. We also briefly talked about what are the AWS services that facilitate this type of connectivity, right? So for network to network, you guys are probably familiar with Transit Gateway. It's been out for years now.
Mhm.
Before that, we had VPC peering. So Transit Gateway, if we start with VPC peering is like this pipe that I drew on the diagram, connecting one VPC to another VPC. Transit Gateway is more like a distributed logical router that can connect thousands of VPCs. And then Cloud One, which launched, I think, 2 years ago, that's imagine like a set of managed transit gateways that AWS manages and deploys for you globally to connect your resources to. And then on the application networking side, most of the last 3 weeks, we went through Amazon VPC Lattice, but there is also Private Link. So that's what I want to touch on a little bit more today. But I want to anchor that also in recapping a little bit about VPC Lattice. So if this is going to be relevant if you haven't seen the shows in the last 3 weeks, so it's going to be just one slide with a little bit of animation, and we'll move on to endpoints. So with VPC Lattice, we still have our application VPCs on the right-hand side, where we're hosting some applications. We'll explain what they are in a second. We have this construct called the Lattice Service Network, which is like a central hub where you register your applications and have your clients connect to it. So if we go through an example here, say we have an application running on EKS, we can configure that as a Lattice service. Lattice services ultimately are HTTP or HTTPS applications and support different types of compute, Kubernetes, ECS, even Lambda. And then you associate this service that you've just created with the service network. You can imagine this to be similar to like an application load balancer style connectivity, where the service association has a listener, let's say port 443, you can hit that listener and you'll get load balance to the pods or EC2 instances or send to Lambda representing your service. The other side of the coin is resources. Resources are just TCP applications. So with services, it's all HTTP, HTTPS, or TLS. With resources, we're saying TCP application, I just need to do nothing from one side to the other to be able to access something in this application VPC. In this scenario here, we have some EC2 instances listening on a bunch of ports I made up. You need a resource gateway to be able to get to resources or resource configurations or to your TCP things. But then you register that resource configuration as a resource association to that service network. We really like the word association. A lot of things here are associated with the service network. So while associating the service, associating the resource, every time we do that, we ultimately registering it with a service registry. So now Lattice knows about all of those different applications that you have. And then you can connect Lattice to multiple VPCs that will be able to consume those services and resources. And there's different types of how you can connect those client VPCs. You can create another association. This time it's called a VPC association. That is similar to kind of like creating an S3 gateway. It doesn't really appear as an interface in the VPC, but it lets you get to things behind Lattice. And then each service and each resource gets its own unique DNS name. And when you're accessing that service or resource using that DNS name, it will be using link local IPv6 or link local IPv4 address space. So clients does the DNS lookup, gets 169.254 for service one. Yeah, it connects to Lattice. Lattice is proxying that connection to the service. The other option we talked about, and that is where already endpoints start coming into play. You can create a VPC endpoint to the Lattice service network. So that VPC endpoint is powered by private link, which is used in other types of endpoints that we're going to talk about today.
Mm-hmm.
And you can create that and you can connect to a service network. The reason why you would use an endpoint and not the VPC association is that maybe you want the VPC to connect to more than one service network. With VPC associations, it's one-to-one. So one VPC can only have one service network. With service network endpoints, you can have as many as you want. And then they're also accessible from on-premise because the DNS names that the resources and services will get while they're behind the service network endpoint are going to be the IP, returning an IP address from the VPC range. So therefore, they're reachable from outside of that VPC.
So you can route to it.
Yeah, you can route to it from elsewhere. So this is a very simple recap. I really didn't want to go into too much detail because I think we gave Lattice justice by really going through a lot of different options.
Mm-hmm.
And today we're going to talk about the endpoints. Right. So let's talk about resource endpoint first, and then we'll talk about the interface endpoints. So with resource endpoints, we're kind of back to the scenario we had earlier. So let's say we have some application running on EC2, and it's using a range of ports, 2715 to 2730. First thing we need to do is just like when we were registering resources with Lattice, we need to create a resource configuration. And I'll show you how to do that in a demo live in a second. But there's different types of resource configurations. The one I want to focus on is a DNS-based. That's a really cool one because that's the first time within AWS that you have the ability to target a DNS name from another service, right? Typically, when you have an NLB or an ALB, when you want to target something, it needs to be an auto-scaling group. It needs to be an IP address. With resource configurations, you can have a DNS name representing the things that you have under that resource. So in my example here, it's appexample.com. If I were to do a DNS lookup on this appexample.com, I will get back the IP addresses of my EC2 instances in that VPC that are performing a function. And I can remove those IP addresses, and then the DNS name gets updated, and I have less resources or more resources, and so on. So I register my resource, or create a resource configuration, but I don't have a service network, so I'm not using Lattice here. I still need a resource gateway. But then I'm creating this VPC endpoint resource association. And ultimately, it will land on a resource endpoint in the client VPC. And I'll show you in the demo on how that setup looks like. But it's very similar to how you saw, accessing Lattice. But in this scenario, you're accessing only a single service. So you're not using Lattice, but you ending up with a single service behind a single resource endpoint, or single resource behind a single resource endpoint.
Hey, Tom, we got a question from hirings. It's hirings, right? Yeah, yeah. The hosted zone must be public, or can it be a private hosted zone associated to the VPC?
Good question. So today, the hosted zone needs to be public. It is. We get feedback from a lot of customers like, give us the private hosted zone option, and trust me, the service team is
Working on it.
hearing that. Yeah. We can't talk about the roadmap obviously, but it's definitely something that we're hearing. But for now, as we speak today, the DNS name has to be publicly resolvable, which means that this appexample.com needs to be a public zone. Even if it points under the hood to these private EC2 instances, it has to be resolvable publicly.
Yeah, pretty much the service needs to be able to resolve it, right? So that's one of the things that we have to look at when we're looking for private hosted zones, is how do we safely and securely do that? So for now, it's public.
Yep. And then from a DNS point of view, there's a unique name that's being generated for the resource, right, behind the resource endpoint. It has the VPC endpoint ID, and then next to it, let me just see if I can draw over this and make it a little bit more interactive. There we go. And then this portion is the resource configuration ID, right? So you can see here RCFG11. So this is going to be auto-generated, and obviously you can alias this to your custom domain name. You might not want to use the nasty VPC endpoint ID, RFCG, whatever. It's quite a long name to remember. So normally customers would convert that to something that makes more sense. After that, the client does a DNS lookup. Let's say the client is using v4, so they're connecting to 10.0.0.15. On the resource endpoint, 10.0.0.15 is directly mapped to this resource configuration we created earlier. From a flow point of view, this connectivity here between the resource endpoint and the resource gateway is powered by private link. So we're transporting the traffic nicely all the way through here to the resource gateway. On the resource gateway, it will do a DNS lookup on appexample.com whenever the traffic starts coming in. So we'll do a DNS lookup, and let's say these IP addresses are 10, 11, and 12. So we'll do a DNS lookup of appexample.com, and it will get IP addresses 10, 11, and 12. And whenever you do a DNS lookup, there's a TTL. So how long does this DNS lookup should live before I need to do another DNS lookup? So time to live. Let's say it's 60 seconds. So TTL is 60 seconds. So every 60 seconds, the resource gateway is going to do another DNS lookup on appexample.com. So if, say, 12 is, you're no longer there, you decided to remove it, you will update the appexample.com, remove 12, and after 60 seconds, whenever resource gateway does a DNS lookup, 12 is no longer going to be there. Maybe you've added 13 or 14. So that's how the resource gateway knows where to forward the traffic to. And then the way it decides, because now it has 3 IP addresses, right? 10, 11, and 12. Which one will it use whenever it's connecting to the backend? So what it will do is it will assign at random, each IP address to different flows. So if the client establishes first connection, first flow, by flow I mean a TCP5 tuple. So protocol, source port, destination port, source IP address, destination IP address. So for that flow, the resource gateway assigns one of the IP addresses, so let's say 11, and then forwards to 11. A new flow comes in, still within the TTL of 60 seconds, and maybe at random it will pick 10, right? So the next flow goes to 10, and so on. So it is random. So you might then go 10, 11 again or 10 again before you hit 12. But at scale, that randomness should be close to kind of a similar to like a little bit of load balancing in there. And finally, again, every 60 seconds, it checks, are these still IP addresses still under this DNS name?
So now that we've got an endpoint on the left-hand side, and we were going to an FQDN that we have in our Route 53, which is up to 3 different machines on the right-hand side, on the consumer and provider, to use the private link. If I want to share this to another account, is it the same as private link, or do I have to do something different?
So yeah, you would have another VPC, another endpoint, and you will have to create the whole thing again. Right. So it's a kind of a one-to-one mapping and that resource endpoint can only get you to this particular resource configuration. So if you have another resource, you would have to create another endpoint. Right. So immediately at scale, if we're talking about, I have multiple resources I want to share, I have a lot of different VPCs, and it's going to be an any-to-any mesh, that's where you need to go to Lattice. Right? If you have a use case where, okay, I have a few VPCs, they need to get to one resource, I don't need Lattice in the middle, you can totally use resource endpoints. And the principles are similar. So this whole thing on the right-hand side that I told you about, how this DNS is handled, how the resource configurations are forwarded, that's the same thing for Lattice. The difference is what is here in the middle. Are you landing on an individual endpoint and then you're one-to-one? Or are you using Lattice, which allows you to have multiple resources in the Lattice network that are exposed to multiple VPCs?
Okay.
Okay, I drew over the tip here. Let me see if I can clear that. It's erase all ink. Yeah. So a single resource endpoint provides access to a single resource. Now we're going to quickly touch on pricing dimensions. We did that in the first session for Lattice, so I thought it makes sense that we kind of touch on it here as well. And we're going to do a case where all of the components are in different accounts, right? We often show everything without the account structure, so I'm just showing you here that we have account A, where the client is in, and then account D that owns the resource. You have to do resource sharing. So the account D needs to share the resource with account A for it to be able to for account A to be able to associate it with the resource endpoint. But when the sharing is done, then from a pricing perspective, there's a charge on the consumer side. So there is an hourly charge here per resource endpoint, and that is 2 cents per hour. Note that this is regardless of how many AZs you deploy the endpoint in. Right, so here it's a kind of all up. So you can have 3 AZs, 5 AZs, the resource endpoint deployed across all of them, and it's still the same hourly charge for the endpoint. And then you have all of these processing charges. So this is data passing through the endpoint and getting processed, and starts at a cent and goes down with volume. And then on the account side, on the account D side, the resource owner, there's an processing fee close to half a cent per gig. So total, if you own both accounts, if you send the gig of data, it would be 1.6 cents per gig.
$1.60.
No, that 1.6 cents.
I know, I'm just kidding.
Yeah. Yeah,
That's pretty
switched
cheap
from
if you think about it.
yeah. We'll compare it to private link in a second, because there is private link option as well, and that has similar kind of charges. But yeah, ultimately 1.6 cents per gig of data going through.
Yeah, that's actually not terrible, because if you look at it, when you're using, say, VPC peering, or when you're looking at transit gateway, to have this kind of locked down flow, very similar to private link, remember that even though, doing some sort of a peer between the two might seem cheaper, any more further forms of locking it down will cost you in either configuration or other services that you didn't think that you might need. So, especially in a partner play.
Yeah. Okay, so that was resource endpoint. It's ultimately pretty straightforward. So if you understand Lattice even a little bit, the resource endpoints probably seem pretty simple, because it's just like connecting to resources, but without the benefits of scale of Lattice. So it's more of a one-to-one relationship. We also have interface endpoints. These have been out for, I can't remember now, Jamie, is it 5 years now, 6 years? How long the interface?
Yeah, at least six, I want to say.
Yeah. So in the interface endpoint scenario, we have some applications on the right-hand side. Then we need to deploy a network load balancer, and the applications need to be in that network load balancer target group. The load balancer will load balance to these targets. This could be a private load balancer. This could be internet-facing load balancer. It really doesn't matter. If you're doing private link, you're probably going to have an internal-only load balancer. And then you need to make that load balancer an endpoint service. And I'll show you how that looks like in a demo as well. But you ultimately, when you do that, you designate the load balancer as, hey, I'll be building endpoints to this load balancer. So I'm making it an endpoint service. And then you start creating interface endpoints. So again, these under the hood, powered by Private Link. But they require a load balancer. So they're not, they don't have the resource gateway. They have a load balancer on the side where you have the service. There is also an auto-generated DNS name, which has endpoint ID, some service ID. Again, it's a custom domain name created, host name created for the service. Most customers have and use a custom domain name rather than this auto-generated one. With Private Link, there's a cool feature where you can automatically create this private domain name, a custom private domain name, whenever you create the endpoint. So if you have, you know, custom .example .net. Say this is your host name, and you want everybody to use the custom.example.net host name when they connect to your service. You can configure that as part of the endpoint service, and whenever users create the endpoints, they can have the option to enable private DNS. So then we will magically make sure that whenever you do a DNS lookup on custom.example.net, you'll get the IP addresses here, 10.0015 and 2001 if you're using v6. You'll get those IP addresses and you'll be directed to the endpoint instead of anywhere else. So even if this is publicly resolvable and publicly it resolves to like some public IPs, if you configure it as part of a private link endpoint service and then you enable private DNS as the feature, we will create a hidden private hosted zone and say custom example.net always resolve to the endpoint.
So the $50,000 question is, if I'm looking at a scenario where I have folks that need to consume something and I want to use some form of an endpoint, how do I decide to use either private link or endpoint services? What would be your recommendation?
Yeah, I have a kind of comparison slide. I think that's probably going to be the best place to talk about it. It's not super clear cut, right? But I think the most like common thing to do would be to, if you have a large scale deployment, you're going lattice, right? If you know that your application is full mesh, any-to-any communication, you want to do lattice. And then if you have a SaaS application that's already behind a network load balancer and you need to expose it, you would use an interface endpoint. If you have a resource that's TCP based that you don't want to put behind a network load balancer that needs to be accessed using a host name, or if you're sharing behind the resource endpoint something like an RDS database, that's where you would use the resource endpoints. So it is ultimately coming down to your specific use case. But if it's a mesh, that's easy. Then go with lattice. That would be the direction. I have a comparison slide, so we can talk about it again in a second as well.
Got it.
Yeah, and then with the interface endpoint service, so if this load balancer, say it's listening on port 443 and maybe on port 80, so you added both, those same listeners are exposed here for the interface endpoint. So the way I like to think about interface endpoints is like a really long arm of the network load balancer with the listener at the end. So you hit this listener here, it's like hitting the load balancer. And then I don't have slides on it, but this is something that you can build. I'm showing you the example of you building it yourself. But in many scenarios, this whole right side would be a partner service. So all of this here would be a partner service or even an AWS service. Right, so this could be CloudWatch, right? So if you want to send traffic to CloudWatch, We take care of managing all of this backend, so you don't have to do anything here. You just create an endpoint for CloudWatch, and it will look exactly the same, and you'll be able to consume it.
So the other question is cross-region.
Yep.
Does this support cross-region? Does resource endpoints support cross-region?
Yeah. So private link or interface endpoints is the only service today that supports cross-region. Let me just show you the quick pricing overview on it, and then we'll do cross-region. So from a pricing perspective, there is an hourly charge here for each interface endpoint, but note this one is per AZ. So for resource endpoint, it was 2 cents, but no matter how many AZs you use, here it's 1 cent per hour, but per AZ. So if you have 3 AZs, it would be 3 cents. And then all of the processing, so traffic passing through the endpoint and getting processed in either direction, the same exact charges. And then on the network load balance side, there's also the network load balancer charges. They're dependent on not just the volume of traffic, but maybe how many connections you have, things like that. I think they might be close. Like I can't remember what's the LCU for network load balancer. If you were to send 1 gig, is it like 0.8, or so 1/8 of a cent, or 1/2 of a cent, or 1/6 of a cent? Don't know,
Let me
Jamie,
look.
if you remember off the top of your head. But
Yeah, I got to look it
ultimately,
up
yeah, it will
because I
be
know
the
I made
1
it.
cent, right, plus whatever the NLB LCU is per gig if you were looking at gigs. So ultimately, that should be very close to the 1.6 we had for resource endpoints. So when we're talking about volume of traffic being passed through interface endpoints and resource endpoints, the pricing should be very similar because we need to account for the fact that the private link endpoints or interface endpoints require a network load balancer.
Yeah, it's 0.008 cents per hour.
Okay, so it's going to be, yeah, so 8 here. Whoops. Let me just tidy that up a little bit.
Yeah.
Yeah, so it's going to be 1.8 cents per gig ultimately. Yeah, so slightly more than resource endpoints, but this gives you load balancing. With resource endpoints, you don't have load balancing out of the gate.
Right.
Okay, cross-region. So with interface endpoints, we did launch support for cross-region access. So it means you can have, or your partner can have, a service in one region, but then have consumers in a bunch of different regions. Most of the time, it probably makes sense if it's a nearby region, right? So in the example here, I have my resources in Ohio and I have consumers in Virginia. Might not be that great if if you have a service in Australia and you're trying to drop endpoints in US. It will work. We have, congestion-free global backbone, so you have the best bet of the network actually delivering for you there, but still there's latency that we can't get rid of. So
Mhm.
typically you would have this more of a, I have a service. I don't want to replicate that service in, all of the AWS's region, but maybe I'll have one service in US and then have everybody in US be able to consume it. And same thing in EMEA and same thing in APJ.
And it's not a bad option either if you're doing something like DR, right? Or you need a stopgap for a migration. You know how those things go when you have all those moving pieces when you're trying to shuffle something from one side to the other. And if I just had a simple way of connecting things while I'm doing something else, this is a good one.
Yeah. The way what I've seen with most customers and some of the software vendors that I worked with is like previously they would have to either build this themselves, which is adding complexity, or be able to replicate the application in every single region, which is also not a feasible model, right? Especially if
Right.
you're just starting in a particular region. You're big in, US East 2, but in US East 1, you don't have that many customers or consumers, and replicating the whole infrastructure would be more painful. Whereas with this, hey, you can consume my service from another region.
Yeah, and then as things fill out or over time, as that region becomes more and more popular, then you can do that. Hopefully, you've got infrastructure as code, and you can go ahead and execute into that region, and you can absorb that
Yep.
running cost.
Yep. Cool. So pricing wise, how does this differ from the pricing for a single region? So endpoints, that's the same. Processing on the endpoint, that is the same. So these are the same. Network load balancer charges, the LCUs, still the same. There is one extra charge here for on the private link side for every region that you decide you want to enable. So in this case, I only enabled US East 1 to be able to consume my service. I need to add 5 cents per hour for every region. So it doesn't matter how many endpoints I have, it's about how many regions I lit up. So if I have 2 regions, that's going to be 10 cents per hour, regardless of how many endpoints. So I feel like that's very reasonable. And then finally, something that's always there if you're crossing regions, like there's a data transfer charges. There's a data transfer across region. That's always there if you're sending traffic across regions. Those charges always are there. The biggest difference here is that normally we charge the sender. So if you're going from US East 1 and you're going to US East 2, we charge a sender a gig per cent per gig. And then if you're going in the other direction, we also charge the sender a cent per gig. In the private link model, we charge the consumer, so the client, for both directions.
So traffic coming out of the endpoint, there's a charge. Traffic going back into the endpoint, there's a charge.
Yeah. So this is I wouldn't even think about this one as like endpoint. This is forget about the endpoints. If you put an EC2 instance on each side in each VPC and you push traffic to the other side, to the other region, those charges will be there. These are just regular cross-region charges. All right. I think we still have time before we jump into doing some show and tell.
Little less than half an hour.
Yeah, so I think we're good. If there's preferences, if folks want to message which thing they want to see first, because we could start with resource endpoints or do private link. I have ways to show you both. If there's interest in one or the other, we can go in that direction. So Jamie, let me know if someone has specific preferences there.
Sure. And hello, Victor. Just wanna. I like saying hello to the folks who say hello to us.
Nice. So the summary here is we have these 2 different models now of connecting. We have service network with Lattice ultimately, and then VPC endpoints. And then service networks powered by Lattice. VPC endpoints are using private link under the hood. So with a service network, we have these 2 use cases that we summarized earlier. We have microservices, so HTTP applications ultimately across multiple VPCs, or just TCP resources, databases, clusters. These are the same resources that you would use a resource endpoint to access. Whereas with the endpoints, you either go to AWS services. We touched on that a little bit, right? So if you want to get to CloudWatch privately, you can create an endpoint for it. We have TCP or UDP behind an NLB. So that's one additional thing I forgot to mention, that we support UDP on private link. So this is the interface endpoint. And then if you're going to TCP resources that are databases, clusters, things that you need to access as a DNS name, that's where you would do resource endpoint. And finally, you can use a VPC endpoint to a service network, right? So we saw that earlier, that whether you can have a service network without using an endpoint to get to it, but there's some benefits of using an endpoint to get to a service network. So service network, many-to-many connectivity. Endpoints is pretty much one-to-one connectivity. So one endpoint for one NLB, one endpoint for one resource, one endpoint for one service network, right? But if you get to a service network, that is like a multiplexer, and you're going now from one endpoint to a service network that has many things in it. So that's a way to switch from one-to-one connectivity to one-to-many while still using an endpoint to get there. Connectivity on-premise, you can access a service network only if it's using a VPC endpoint. Otherwise, from on-premise is not accessible. And that is always, regular endpoints are always reachable from on-premise rather than resource endpoints, interface endpoints, or so on. Cool. Any suggestions in the chat on which direction folks want to see a demo?
I think they're just happy to see what you're seeing. We've got Brian
Okay.
saying thanks for the great presentation. So I think it's really up to you, Tom.
Okay, so let's start with resource endpoints, because those are less common. Let me see, zoom in here. And I'll maybe draw out the environment as well in parallel, so you see what we have here. Let me close that presentation. Okay, So we'll have a pretty simple scenario where it'll be in US East 2. I have a client VPC in here. And I'll have a EC2 instance as a client. And then I have how did I call it? Let's see. Let's look at my VPCs. Client and a provider. So we have a client and a provider. Everything in the client is 10.201. Everything in the provider is 10.200. And then I'll have a EC2 instance that's going to be a resource in here. And then in here, I have a client instance. And we'll try and get from the client instance to the resource. That's going to be the name of the game. And we'll do different options on how we're going to do that. Okay, so let's start with the resource endpoints. So on the private link and lattice, we now have quite a lot of things in here. So we've added
that's
a bunch of stuff.
expanded just quite a bit.
Yeah, I know. On one hand, we're adding these things to make things simpler, but at the same time, initially, you kind of have to understand what's going on in here. First thing we need to make sure of is we have a resource gateway, right? Because if we're creating resource endpoints or if we adding resources to Lattice service network, we need to do that always through a resource gateway. So I took the liberty of already creating a resource gateway. And there's not much to it, right? When you create it, you give it a name, you decide which VPC it's going to be in, you give it a security group, and that's pretty much that. You're done.
That's
right?
it. Yeah.
That's it. So we can add it now to our drawing. So in here, I'm just going to use a different color for resources. So now we have a resource gateway here in this VPC. And when it gets created, it's going to get a bunch of IP addresses. It's going to get a /28, so that's 16 IP addresses from our network. So it's going to have 10 to 100, 16 IP addresses here, contiguous IP addresses grabbed from our provider VPC. Okay, so we have a resource, but we don't have any resources, any resource configurations. So we can start creating resource configurations. And actually, let me just get to EC2. So I can pull out the IP addresses of the thing that we want to get to. So create a resource configuration. So we'll call it resource config. So, and then in here, you see that you can either create an individual resource or a resource group. Resource group can have child resources in it. And it's useful when you are using resource endpoints, right? Because with resource endpoint, you can only attach one resource to that endpoint. And that resource could be an individual thing, an individual resource, or a resource group that contains multiple resources underneath. So that becomes super useful if you're talking about exposing things through a resource endpoint, not through Lattice.
And if you're exposing, just a quick note for the resource group, those bits in the group don't all have to be the same thing. So if you're doing something that's based on IP or EC2 instance, and then you maybe want to add an ARN and possibly maybe an FQDN, you can add them all to the same group. But just understand that you don't want your groups to become junk drawers. Just shoving everything in there and sharing it without realizing or without happenstance.
Yeah. And the questions I had is like, okay, so in resource group, if I add 10 resources, is AWS, how is AWS going to pick these resources? How do you send traffic to them, right? Are you load balancing? So think about it just as a configuration container. So if in your resource group, you will have 10 resources, and then you attach it to a resource endpoint, you'll get 10 IP addresses, 10 unique host names. So they still are independently showing up as individual things. The resource group is just a grouping to wrap them together on the configuration side. It doesn't do anything else in terms of, I'm going to load balance between all of the child resources, things like that.
Right. Yeah. So think of it like also it's still one endpoint too. So for all our folks who are Unix friends or people who are used to working on Cisco's and that, think sub interfacing.
Yeah. Okay. So
we do have one question. It was just really cool from EXNI. Actually, let me just put it over here. He wants to see Lattice in combination with VPC endpoints to reach on-prem. So make that happen too. But
Yeah, I think time-wise might be hard. All you need to do is create an endpoint. So endpoints take an IP address. So in here, we can extend the drawing. We want to have time to do it, and it's very easy to simulate on-prem by just connecting, even another VPC to this client VPC.
Mhm.
If I have an on-prem here, so I just say on-prem, and I have any type of connectivity to this VPC, so DX, VPN, and there's an endpoint in that VPC, whether it's connecting to an individual resource or if it's connecting to a service network, I can get to it. Like it's an
Right,
IP address that I can route to. So as long as I can get to 10.201, I can get to anything in that VPC.
right.
Uh,
And then the one other question you had, a little more serious. How many IP addresses does the resource gateway actually take up?
16, yeah. It grabs 16 IP addresses out of the gate, and then that will accommodate 16 resources. If you need more resources, right? So what's going to happen is that every single resource behind the resource gateway will pull an IP address from the resource gateway as well. So it's kind of like a one-to-one NAT. So I'll show you what happens on the client side, but ultimately every single flow to a backend resource will pull an IP address from the resource gateway. So out of the gate, you get 16 IP addresses that are taken away. If we need more, the resource gateway will pull another /28, and we'll keep doing that until you hit the limit, which I think today is the default limit is 100 resources,
Yeah,
if I remember correctly. And I think that's adjustable as well if you need to.
yeah, it's a soft limit,
Yeah,
as we like to call, or soft quotas. I think we're calling them now.
yeah, soft quotas or soft limits. Yeah.
Limits, quotas.
All right. So
Potato, potato.
we're going with our resource configuration. We got to specify which resource gateway it's going to be behind. So we have it here. There's different types of resources. So we're saying it's going to be a single resource. We're not going to put it into a group resource as a child. The cool thing here is that you can also have RDS today as a resource. So your our RDS service, our database service, relational database service, you can put that behind a resource, create a resource configuration for it and then access it through a resource endpoint, not through Lattice.
And the benefits of the yarn is that if your database grows or shrinks, the yarn will automatically stuff in the children of those nodes that it consumes, which is kind of cool.
Yep. So now we're defining the resource. If I don't have a DNS name that I've set up for this, so we're going to just set it up as an IP address. So I have my resource instance here, copy the IP address, and we'll just point to it. Okay.
No
So,
off-screen magic copy paste here. You can see everything that he's doing.
yeah.
At no point does Tom's wrists leave his hands.
Yep. Yep. I'm sharing a full screen, so I went wild.
Yeah, he went wild.
Yeah. We're opening up all the ports. That's fine. This is if you want to allow this resource to then, when it's shared, to be associated with service network that can be shared further down the line. So there's like a chain of sharing. If you want to allow it, you can, or you can not allow it. For connecting to a resource endpoint, it's not super relevant.
So one thing I want to point out too,
Mhm.
Tom, that you just you went over with the port ranges. One of the big differences between resource endpoints and using private link with an NLB. With the NLB, you don't have the options, such options of the port ranges as you do with resource endpoints. So that's one thing to consider when you're making your decision as to the best way to share out your resource.
Totally. Yeah, I think that's a good call out. Okay, so we just opened all the ports. I have it listening on port 80 and 2020. This resource is actually a HTTP application because it will allow us to return some information about what it's seeing from the request, but this could be any type of TCP-based application.
Mhm.
And then we're going into endpoints, and we're going to create a new endpoint. So this is going to be our resource endpoint. There's a lot of different endpoint.
Yeah, I was gonna say, look at all the types.
Yeah. So we have, you can get to AWS services. So like that's the CloudWatch. You can get to partner services, services from Marketplace, EC2 Instance Connect endpoint. I don't think we'll have time to talk about it, but that I'm
No.
using that for the show. I'll show you in a second how I'm connecting to the EC2 instances because that is super neat. And for here, we're going to connect to a resource. Okay, so because we're in the same account, it's already in here. If we were in different accounts, I would have had to share the resource with the account that creates the endpoint, but I'm going to select that. Select the VPC. I'm going to put it in my client VPC. there's an option to enable DNS name. It isn't. Is it only relevant if you're sharing an RDS resource?
Right.
If today, if it's not RDS, if it's my own resource, even if it's a DNS-based resource, that DNS name doesn't do anything. So I'm just going to leave it off. Pop it into a couple of subnets. Let's say put it in the private subnets. Make it IPv4. Sorry, Alex, you're not on the call.
Well, she was supposed to host today, but
yeah. And then I have a security group that's fairly open, just to not cause drama. Okay, so what we've done here is we now said, I want a resource endpoint in my client VPC that will, through the magic of private link, be able to use the resource gateway to connect to my resource. And we'll see how the client finds out about the IP address that it needs to connect to be able to get to my resource. While this is happening, looking at time, I think let's do private link in the background as well, so we can see both side by side. For private link, I already have a load balancer created. So I have an NLB, aptly named NLB here.
I was going to ask you how you're going to fit creating an NLB in the time remaining.
Yeah, no, it's already there. It's already there. It's listening on port 2021, and then it's sending stuff to a target group on port 2020. So that's my instance that's listening on 2020. You can see it's healthy, so we can add these elements here, maybe in pinkish. So we have, actually, let's make this bigger. So pinkish is going to be, we'll have an NLB that's already load balancing here. And what we're going to do is create a regular interface endpoint.
Right, unidirectional, stateful flows, all that fun stuff.
Yep. So back to our VPC situation. We want to create an endpoint service first. We don't have an endpoint service. So create an endpoint service, endpoint service. We're going to pick our network load balancer. We're going to select the region. So this is interesting. We can say here which regions, other than the region that we're deploying in, we want to enable private link. So I'm actually going to add Virginia. If we have time, I'm going to show you cross-region access. I don't want to do acceptance. You definitely want to do acceptance in production. Otherwise, you're just basically making a public load balancer. Or
and poking a whole bunch of holes in the environment.
Okay, so this is creating, let's look at our endpoints. Our resource endpoints already up and running. Okay, so let's look at them. So this is an endpoint. We can see that there's a resource associated with it. And in here, far to the right, there's going to be the DNS name that got auto-generated. Like, I'm not going to use custom DNS. I'm going to use the auto-generated DNS name. Interesting thing here, if I do a DNS lookup on this publicly, it returns my private IP addresses, 10.201. So this is the VPC. If you remember, 10.201 is my client VPC. So those are the IP addresses on the resource endpoint. That host name is publicly resolvable. Okay, so I'm going to go on the instance. Let's go on the client. This is where we're going to use the EC2 instance connect endpoints to actually SSH into the instance. I don't even have an SSH key on that instance.
It is very cool.
This is going to be our client VPC. Let's clear this. This guy can do a DNS lookup. Oops. Dig. Sorry. Yep. So DNS lookup works. Let's curl to this host name, and then we said I think it listens on port 80, so that works. There we go. We're hitting our resource. This is the server IP address of the resource itself, so 223.243. So let's double check that. 2243. That is correct. Remote client IP address. So what is the server seeing as what is connecting to it? And it's seeing the IP address from its own VPC. That is the IP address on the resource gateway.
Mm-hmm.
And there's no X forwarded for, because this could be any TCP application. I have it in here in case I'm doing different models. It shows the host header and then picks up the port from the request. I can show you that it also listens on port 2020, and that works great. Okay, so that's pretty much it on the resource endpoints. Let's see if we can create an endpoint quickly for interface endpoints. So this is our service. Where is the service name? There we go.
And as Tom is doing that, just so you know, when you're looking at your resource endpoints and you're looking under that tab where he was showing you the DNS name, if you were using a resource group, if you would have slid over a little bit more, you would have seen associations tab. And that associations tab will give you the FQDNs for each resource that's hidden behind that resource group. Just a note. Also, it's kind of easier. I always just tell people to do a describe call, but if you're into using the console, you can do that too.
Okay, so I'm creating an endpoint. I'm going to show you very quickly. We might not have time to show you the access, but I want to show you creating a cross-region option. So we've enabled cross-region support for endpoints for our endpoint service. So I've just changed region. So everything I had was in Ohio. I'm in Virginia. So I'm going to create an endpoint here. Interface endpoint. This is cross-region. So I'm connecting to an NLB endpoint service. That's the service name that I pulled from the endpoint service details. So if I go to endpoint service, I can see the service name here. If I verify the service here, there's an error, can't be verified because that doesn't exist in Virginia. So I have to go, oh, actually, this is cross-region and this lives in Ohio.
Got to tell it
Then if
there.
I verify it, oh yeah, it knows it's there. Select the VPC. I have another client VPC, this done 10203. The one in Ohio was 10201. And I can create the endpoint just like I would any other endpoint. So I'm
So
going
you're
to
not going to show off the IP overlap features?
No, yeah, I thought about it, but then I was like, it's going to be confusing if I use the same range everywhere. And
yeah, like if you try to use that VPC to demo something else and now you can't connect it with a cross-region peer.
yeah. Okay, so I think we're gonna wrap up. Let me just try and connect to the interface endpoint from our client. So clear this, and then I need to find the endpoint in Ohio. Actually,
The new
I
one.
won't show you. Yeah, I won't show you the cross-region, but I'll show you the in-region connectivity. So this was our interface endpoint. When it gets created, it also comes with a DNS name that's publicly resolvable. So I can do a dig on it. And then I can curl, but you'll find that I can't get to port 80 because I can only open one port or one port per listener on the NLB. So even though for resource endpoint, I opened a range of ports, I could get to 80 and 2020. Here I can't get to 80. I can't even get to 2020 because on the listener, I set up 2021. So load balancer is listening on 2021 and then converting that to 20 when it connects to the actual server. So you can see here, if this is a regular endpoint, so you can see the VPC endpoint ID, then the VPC endpoint service ID, and then the region and the domain. Okay, and I think we're
Just about out of time.
just about at time.
Yeah. Hey,
Any?
here's a question about your drawing. Like, what do you use? What is a canvas used for drawing? So how
Oh,
are you doing those cool things?
so I use, this is just Notability. It's like the Paint equivalent for Mac. So there's a free version. I think I had to get the paid one because I draw so much that it blocked me from doing all the drawings. And then I have this. This is like a, I don't know if folks can see it on the screen, but this is just
Yeah,
a Wacom pad I spent $40 on from Amazon. I like it because, I can throw it in the backpack, will not get damaged. Even if it does, it's like $40. I thought about an iPad, but then I'm going to damage it the amount of time I'm like
you're
throw
not
things in the
gonna
backpack.
damage it. It'll be fine.
Yeah.
We'll get you in an iPad at one point or
Yeah.
another.
The only thing I would say about this, it takes a while getting used to because you're drawing and you're not looking at what you're drawing. I have to look at the screen when I'm drawing, not look at the actual pad when I'm drawing, right? Because I don't have anything here. It's just a black surface.
But it works.
Yeah, does the job.
Right. Now, just as a final, we have like I think 5 minutes left, a little less. What do you want folks to take away from this conversation, Tom?
Yeah, I think the biggest takeaway is if your environment gets bigger, look at Lattice, right? If you have a many requirements, look at Lattice. And for more specific use cases. So if you have an application already behind an NLB, or if you need to expose UDP, or if you do cross-region, that's where you can look at interface endpoints. Resource endpoints are useful for those one-off use cases when I have a resource that I want to connect. But even with larger software vendors, the likes of like big companies that rely on private link, and now they're looking at resource endpoint and Lattice. For them, it's easier to just use Lattice because they can have their customers throw a bunch of things into a Lattice service network and then make that available to that software vendor to consume things through.
Makes sense. Well, Tom, always a pleasure. Glad I could have a chance to host you a second time.
Yep.
And yeah, look forward to seeing you all again. Someone is they're getting a last minute question. Can you tell us what's under the hood for Lattice SSL tunnels, pseudo wires, EVPN? Lots of black magic and voodooism. We'll be happy to do a deep dive at a later session. We can talk about how all that kind of gets strung together and what it does. But also, if you need to get in contact with myself or Tom, we're both pretty well versed, and Alex, who is really well versed in Lattice, just reach out to your account team, and we'll be happy to talk to you about anything that's NDA-ish, like what's under the hood.
And roadmap.
And roadmap, yeah, that too. Well, thank you all for joining.
Cool. Thanks, everybody. Thanks, Jamie.
Yeah, always.